Okay, so now I want the integral -1 to 4 f of x dx. But I don't have -1 to 4. I have -1 to 1, 1 to 4. Add them. So this is the same. We're going to use correct notation. This is the same as the integral -1 to 1 f of x dx plus the integral of 1 to 4 f of x dx. And what's the integral from -1 to 1?
5.
And from 1 to 4?
-2.
-2. Which tells me my answer is 3. Now, by the way, that integral of 1 to 4 f of x dx is -2. What does that tell me? That for the most part it's below, right? Because it could have some that's above and just cancels out, right? But for the most part, most of it is below. Okay, let's do another. I have the integral -1 to 1, 2 f of x plus 3 h of x dx. I'm going to go ahead and use two properties here. I know that if I have addition, I can split it up into two integrals, correct?
Yes.
I also know I can take constants out. So this is the same thing as 2 integral -1 to 1 f of x dx plus 3 integral -1 to 1 h of x dx. So I used two properties there. I broke it up and I took my constants out. Which gives me 2 times what was -1 to 1? 5. Plus 3 times 7. Be 10 plus 21, 31. Yes. Very big, 31.
That
I don't know
number
if we
is
can
so
work with
huge.
those numbers.
That number is giant.
Okay, next one. The integral of 0 to 1 f of x dx. What do I do?
Would you do the s?
Not s, it's an integral.
Of -1 to 1 f of x dx plus 1 to go.
Nope, you can't show it. I literally just want to find from 0 to 1.
You divide it by 2.
That's what I was hoping somebody would say. Because that's the reason I'm giving you this problem. Is most people think, well, if I know from -1 to 1, right, can I just take half of that? But the problem is, what if your function looks like, woo! You take half of it, that's not exactly an equal measure, correct? So, this one is not enough information.
I love those.
But a lot of people do want to split it in half, which would work on one condition. When would I know that I would legally be allowed to just cut that in half?
If it's symmetrical.
If it's symmetrical, give me another way of saying that.
True.
If it's even.
If it's even. Yes? So you might be told on the AP test that, hey, f of x is an even function. In that case, if that's all I have to add. If they said f of x is even, boom, this one's possible, divide by 2. Okay? So you have to use a little bit of thinking here.
This one where you just introduced Ryan to his new favorite 3 letters.
Uh-huh.
Well,
Integral -2 to 2 h of x dx. What do we think? Can't do this one either for the same reason. A lot of people want to double this, right? Because they know -1 to 1, -2 is going to be twice as much. No, because you could have a function, it might be, here's -2, -1, 1, 2. If I have a function that's doing something little, boom, boom. So you can't double it because it's going to give you way more area. So not enough information. Last one. negative 1 to 4 f of x plus h of x dx. I'm going to go ahead and break that up. Negative 1 to 4 f of x dx plus the integral negative 1 to 4 h of x dx. Didn't I already find negative 1 to 4 up in one of the other ones?
Yes.
Yes? I did. Part B, correct?
Yeah.
That is 3. Negative 1 to 4 h of x dx.
Isn't that just-
You can't do that. The only information you have on h of x is from negative 1 to 1. That's the only information. You do not know what's going on from 1 to 4 for h of x.
So 3 plus not enough information.
3 plus not enough information is
3 plus any I.
not enough information. Let me give you one more common mistake one. Go negative 1 to 1 f of x or f of x h of x. This one is missed all the time. Now do not write what I'm going to write. This is what I see. Negative 1 to 1 f of x dx times negative 1 to 1 h of x dx. And this was what, 5 times 7? 35.
True.
Can't do that.
I can get an answer. Everything I have is up there. I have the information from negative 1 to 1 f of x and negative 1 to 1 h of x, correct? But if I go back here, I have absolutely no property that says I can split up multiplication. Which in fact, we know we can't. Because think back to derivatives. If we have multiplication, it's not just take the derivative of each and multiply, right? It's the product rule. And actually integrals are backwards derivatives, so we know it's not true backwards either. So, no, no, no. So that one would be not enough information.
Any I.
Because you have no property that says you can split up multiplication. In fact, we know it's not true.